The word momentum is quite often used in everyday life. We have some idea what it means. Like if we say that, say we have a body, okay, it's moving. Now, if there's a body moving, we think that it has momentum. But the sort of ideas that come with momentum is that if something has momentum, it is not so easy to stop. Like if you have convinced yourself to start studying very hard, and you're actually doing it, then hopefully this will give you momentum to keep studying, and instead of stopping and finding something more interesting to do. Okay, so that's momentum. Or if I have a big and massive, more massive body, okay, maybe going at the same speed. Let's say, okay, so both going at the same speed, but one has a bigger mass. So this is the M. This is a bigger mass. I'll call it big M. So we might imagine that if both are going at the same speed, and then the one with the bigger mass would be harder to stop. Okay, or okay, let me change that to U instead. Change the velocity to U. Or if I have say the body with the same smaller mass. Where should I draw it? Maybe here. If a body with the same smaller mass, okay, but it's going much faster. Okay, same mass, little m, going much faster. And compared to this one, you would expect that the same body going faster would be harder to stop. And we often describe this by saying that it has more momentum, right? Like if it's going faster, it has more momentum, or if the body is more massive, it has more momentum. So something that has more momentum is harder to stop. That actually is a property of the body having mass. So, but from what we can see here, even in everyday usage, we often, maybe unconsciously, right, relate momentum, the idea of momentum. Right, we often connect this with the mass and the velocity of something. So, and in physics, momentum is defined quite precisely. Now, momentum is usually represented by the symbol P for momentum, and is always defined as exactly equal to the mass of a body times its velocity. So this is momentum, just mass times velocity. So let's put in some numbers just to get used to this formula. For example, let's say this ball has a mass of 0.5 kilogram, and it is moving at a velocity of 3 meters per second. So what would be its momentum? Its momentum would be m times v, mass times velocity, equals to 0.5 times 3, and the answer is 1.5. And we must not forget its unit. Its units will be kilogram meters per second. So kg m stroke s. That will be its units. So here we have momentum. Now another thing that is important about momentum is that if you look at this formula, it's mass times velocity. Now remember, velocity is a vector. So actually, to be very precise, we must not forget that velocity has direction. So when we multiply it by mass, if we multiply mass itself is just a number, simple number, no direction. So if you multiply a vector by a number, okay, the answer is also a vector that points in the same direction as the vector, as the velocity in this case, but we might imagine that it has a different length because it gets multiplied by a number. Okay, so the length becomes multiplied by the mass as well. So we can imagine that if this arrow represents the velocity, then the momentum could be represented by another arrow pointing in the same direction. Okay, so momentum would always be in the same direction as the velocity. Okay, but the actual magnitude is multiplied by m. So when in this case I've calculated an answer for the momentum as 1.5 kg per second, you must not forget that the complete answer for the momentum is not just 1.5, it's 1.5 and in the same direction as the velocity. Okay, if I want to be very precise, I would add 1.5 kg meter per second in the direction of velocity v. So that's the complete answer for the momentum p, right, which is a vector.